Now, so like I said, I mentioned that we'll start looking at computer hardware, and for us to begin, I'm just going to go through the objectives so that we are aware of what exactly to get out of this unit, even as we learn. So the first thing is that by the end of this unit, we should be able to describe what a hardware is, and also to classify computer hardware according to usage. Okay, and also give examples of each category of a computer hardware. Also to identify different ports of a PC. The other one is to identify why your computer is slow. Also to identify the factors affecting what performance of a computer. Okay, so what is a computer hardware? Any ideas what a computer hardware is? Okay, I'm just going to explain what a computer hardware is, then we shall proceed. So a computer hardware, basically, it refers to all the tangible parts of a computer. Okay, it refers to all the tangible parts, everything that you are able to see and touch. That with regards to a computer is called a computer hardware. Okay. So all the physical equipment that are involved in order for a computer to function, they are referred to as a computer hardware. Okay. So the other thing we should take note of is that a computer hardware is divided into four many parts, and these parts, they are the ones that help us from the time that we add input to our computer until we get the results. These are the parts that are involved. Okay, so the first one is the processing devices. The second one is memory devices. The third one is the input and output devices, and the last one is the storage devices. Okay, I've mentioned that the computer hardware, it's all the physical parts or tangible parts that we're able to touch, and it's divided into four main parts or categories. Okay, the first one being processing devices, the second one being memory devices, the third one input and output, and then the last one is storage devices. Okay, so we are going to look at the diagram that is summarizing the classification of these computers. Apologies, I don't know, I have an allergy, I don't know what I've just now. Okay, so this diagram basically is trying to give us a summary of the classification, okay, of computer hardware. So we said the computer hardware is divided into four many parts. The first one being processing devices, the second one being memory devices, the third one being input stroke output devices, and the last one being storage devices. Okay, so you have to make sure that we are familiar with this diagram, which is classifying computer hardwares. The next diagram is basically apologies for that. The next diagram is basically trying to help us understand how these devices how they interact with each other in order for us to get the results that we want. Okay, which is basically the computer architecture and organization. How the devices, which is the process devices, and also the input and the output devices, and also the memory devices and the storage devices, how they interact with each other in order for us to get the results that we want from a computer. Okay, it's so much noise. Are you able to get me?
much. I'm able to get you.
All right, great. Yeah. So basically, that is the architecture and organization of a computer. How the parts interact with each other. So on top there, we have the main memory, which is on the first part here, and in between we have the central processing unit. Okay, we are going to discuss this in depth, and then we have the central processing unit which has the what, the ALU, and also the what, the C, the CU, which is the control unit. Okay, and then at the end here we have the what, the input and the output. Okay. Okay, so now we are going to start discussing these.
Sorry, madam.
Yes.
Just sorry for disturbing you.
No, it's okay.
Meaning the central processing unit comprises of all these which is on the diagram.
The central processing unit, it has yes, definitely it comprises of all these parts. Okay. But sometimes the main memory cannot. Sometimes the main memory is usually not part of the central processing unit. Okay. The central processing unit is what is in between. The central processing unit has the arithmetic logic unit and also the control unit. Okay? And then the main memory is alone, and also the input and the output devices are alone this side. Okay? So sometimes the main memory is part of the CPU, sometimes it's not part of the CPU. Okay?
Okay, yeah.
Yes. So we are going to start talking about the four divisions of the computer hardware. And the first one, we're going to look at the processing devices. Okay, mainly we are going to talk about the CPU, and we'll be able to understand how it works. Okay, so CPU basically it means central processing unit. Central processing unit. And basically the CPU, it's we can think of it more like a brain of a computer, the same way that we have a brain that helps us to think, to make logical decisions, and to decide on what we are going to do on certain things. Basically that is how the CPU is. Okay, so it runs the computer programs. Okay, and it's also a set of instructions. Programs are a set of instructions. So the central processing unit is the one that helps these programs to run. Okay, it is called a computer processor, or a brain of a computer. Okay, there are two major components of the central processing unit. These are just the major components. There are other small components such as the registers. Okay, but then the major components is the arithmetic logic unit and also the control unit. Okay, the arithmetic logic unit and the control unit. Okay, the control unit, it basically it controls the flow of data through the processor. Okay, it is the one that decides, that tells the arithmetic logic unit how a certain program is going to be handled, or what exactly is to be done to that program. That is the control unit. Okay, and then we have the arithmetic logic unit. The arithmetic logic unit, basically it is the one that is involved in making arithmetic and logical decisions. Okay, so it performs arithmetic and logical operations, which is the arithmetic logic unit. That is basically where the name is coming from. Arithmetic and logical operations. So it's the one that does that does the mathematics and also makes decisions on what output to give you after it has been guided by the control unit. Okay, do you understand the difference between the control unit and the arithmetic logic unit? Okay, so basically that is the difference. Okay, I'm just going to read this so that the computer program, like we said, it's a set of instructions and they must be stored in the memory for a computer to be able to do it, to process them. Okay, so the central processing unit uses the control unit to execute these instructions. The control unit is going to execute a program and then it's going to do what? To direct and coordinate the the arithmetic logic unit on what exactly that program should do. Okay, and then when that happens, the arithmetic logic unit is now going to do what? To perform the actual thing that has to be done on that program. Okay, whether it's comparison or logic operation or arithmetic operations, whatever it is, the arithmetic logic unit is the one that is going to do that. Okay, is that clear about the arithmetic logic unit? All right, if it's clear, we're going to move on and look at the memory unit, then the memory devices. Okay, so as we know that in computers, data is represented in what? In binary, which is ones and zeros. So basically that's what it means here when they say a character is stored in what? In the computer as a group of what? Ones and zeros. So a character could be a letter, it could be a number. So whatever character you enter, could, for instance, if you enter A is going to be represented in a computer using what? Zeros and ones. If you enter 2, 2 is also going to be represented using what? Zeros and ones. Okay? Then the other thing we have to know is what is the computer memory. It's measured by the number of bits. Okay? The number of bits which are available. Okay? So the following equalities give the measuring unit for for the memory. Okay? So we have 8 bits which are equal to 1 byte. Okay? 8 bits are equal to 1 byte. And then 1024 bytes, they make what? They make 1 kilobyte. Okay? So basically this is how the size of memory is measured. That's how come you're able to say, okay, my computer has the CPU of my computer is maybe 120 bytes, or maybe kilobytes, or GBs, or MBs, and also terabytes, because these are the measurements that are used to measure the size of memory for a computer. Even the memory cards, there's 4 GB, which is 1024 MBs, which is 1 GB, which is 1 GB. Okay, when you say my flash drive is is 16 GB, you're basically trying to tell us that there's 1240 times 16 gigabytes in your that is the size of your memory. Okay, so basically that is how. Sorry.
So when you have a 16 GB, it has to be multiplied by 1024 MB.
Exactly. And then you get how many gigabytes they are. You get how many MBs they are. Yeah, basically that's it. Okay. What else can we talk about under this? So I'm just going to read this. And while performing a processing operation, a processor needs a place to temporarily store instructions to be executed and the data to be used within that instruction. Okay, so this is where I'm going to build up from. While you are working on something on your computer, for instance, right now, this application that I'm using for class is running. Okay, So while this instruction is being executed, while it's running, there's need for temporary storage. Not permanent, no. Whatever I'm doing right here, it's temporarily stored. For me to be able to see, for the class to be able to run, it's temporarily stored. Once this computer goes off, everything will go off, right? The class will disconnect, and when I switch it on again, I have to start afresh connecting. You understand, right? You understand what I mean by temporarily, right?
Yes.
So basically, this is where the RAM, the random access memory, comes in. The random access memory, it's volatile, okay? Meaning that it will only keep data as long as your computer is on, okay? So it's a small memory that is capable of memorizing temporarily. So as I am working right here, it's able to memorize and able to keep exactly what I'm working on right now. But as soon as the power is disconnected or anything happens and the computer shuts down, if my computer is a desktop computer and maybe power goes off right now and then it shuts down, then everything is lost. Everything that I'm working on right, which is on the screen, it will be lost. When I switch on, I have to start afresh. I have to open everything again. So what is holding what I'm working on right now? It is the RAM. It temporarily stores the programs and instructions while you are working on them and while they are being executed. Okay, so you can read and write to the RAM. Okay, meaning you can add data and also get data from it. That's basically what reading and writing from it means. Okay, so the RAM determines the computer's speed. That's another thing that you should know. Okay, so a computer which has a small RAM, it determines the speed of a computer.
Oh, okay, RAM.
Yes, a RAM, a random access memory. If your RAM is small, your computer will be slow. If your RAM is big, your computer will be fast. Okay, so as you're buying a computer, you have to decide, do you want a computer, do you mind about the speed of a computer? Because there are certain functionalities that you probably want to use that computer for, and it would be expected that your computer is supposed to be faster in order for those things to happen. For instance, if you want if you want to buy a computer for games, definitely you have to make sure that the RAM is big, okay? Because you need a computer that is faster, okay? So there are different sizes of RAM. There's 2 GB RAM. There are computers with even maybe 1 GB RAM, But if you want a computer that's faster, maybe you can get maybe 4 GB RAM, even 8 GB RAM. They're such big computers. 16 GB RAM. Then you know that this computer is fast, okay? So we are going to proceed. Is it clear about the RAM? I've mentioned that it's non-volatile, which means that it will only store data while the computer is running, meaning while the computer has power. That's what volatile means, basically.
Actually, I'm clear.
Okay, great. So then other one we'll look at is the read-only memory. Okay, so we've established that the RAM is volatile, okay, but the computers, they need a non-volatile memory in order for them to read larger programs, and they also need to store programs permanently. Okay, that is why they need a RAM or a memory. I mean, a memory that is that is non-volatile, so that it's able to store certain instructions and programs permanently. Programs such as maybe programs that help you to switch on a computer, and also to insert a password, just for your computer to start. Such kind of a program, they have to be stored permanently. Okay, you're not going to store them temporarily so much that every time that your computer shuts down, you have to start afresh installing programs that are going to help it go on. No wonder that's where the ROM comes in. Okay, so it is a program which is needed that helps you that help the computer to do what? To start. Okay. So the programs, such as the programs that help you to, the utility programs, if you want to reboot your computer, for your computer to start, and also for your computer to be able to understand certain programs that are going to feed it, you need those programs are stored in the ROM, which is the what? The read-only memory. Okay, this memory you can only read from it. You can't add content on it. It's not going to store any content apart from the one that it already has. Okay, I mean that's what basically what it means when you say read-only memory. So these pictures basically they are examples of how the RAM looks like, and also the ROM on the other side, how it looks like. Okay. The other type of memory that we're going to look at is a cache. A cache memory. Okay. The cache memory is basically there to improve the processing time for your computer. Okay. It helps your computer to do certain tasks more faster. How does it do this? So what a cache is going to do, the first time that maybe you access a certain program, right? The first time that you access a certain program, the control unit is going to get that program from the what? From the memory, which is the what? The RAM or the ROM. Okay, I mean the ROM basically. Okay. So it's going to get that program.
Just come again
On the cache?
Hello?
On
yes,
the
on the cache. There's just you are bumping.
Oh, okay. So I was saying the way the cache memory works, it helps the what? It improves the processing speed for the computer. It reduces the time that is required for a computer to get an instruction from the ROM and then take it into the central processing unit for it to be processed. The cache is more closer to the processing unit than the what? The memory unit. Okay. So what the cache will do is that if the first time that you get an instruction from the main memory and then it comes into the central processing unit to be processed, the cache is going to sort of like keep that instruction. Okay? It's going to keep that instruction so that the next time that you want to use that same instruction, you don't have to go to the main memory. No, you're just going to access it right there on the what? On the central processing unit where the cache is. Understand that?
Yes, I understand.
Yes. So it's going to keep instructions which are frequently used. Okay? So much that you can easily access them. You don't have to go back to the main memory and get them again. So this picture basically illustrates how the cache works. Okay, you will notice that the cache is more closer to the what? To the CPU. Okay. Can we move now? Can we go to input devices?
Yes.
Okay, great. So basically, input devices, these are devices that help you to input data into the computer, to enter data or to give the computer instructions. Okay. If you want to type an assignment and then you start typing on the keyboard, that is input. Okay. If you want to record something, you switch on your microphone on your computer, that is input. Okay. So input is basically any data or instructions that you're going to enter into the memory of the computer. Okay. Basically, that is what input is. So once you enter that input, the central processing unit is going to access it and process it and then give you output. Okay. Then here there are 4 types of inputs. The first one is data. Okay. So data is a collection of unorganized facts that can include words, numbers, pictures, sound, and videos. Okay? So data is unorganized facts and they do not have meaning, they do not make sense. That's what data is. So a computer manipulates and processes data into information. Information is now useful and it has meaning and it can help you to make decisions. Okay? So you have to know the difference between data and information. I hope you've gotten it. Great. So the other one is a program. A program is basically a series of instructions that tells a computer how to perform certain tasks. Okay? Or also how to process data into information. Okay? So programs are kept on storage media such as floppy disk. You can have a program, a software. A program is basically the codes that programmers write. It's a program, so it's going to give instructions to a computer. So you can keep it on a CD-ROM or a DVD-ROM or a floppy disk, a flash drive. Then you're going to insert it to your computer and then you're going to run it. Okay? Yeah. Then we also have a command. A command is an instruction given to a computer program. Commands can be issued by typing into the keywords or pressing special keys on your computer. Okay? For instance, if you say Control and C, that is a command. Okay? And you also maybe you press Control and P, that is also a command. Okay? You can use special keys using the keyboard. Okay, so some keyboards include keys that send commands to a program when you press them. Okay, instead of you having to remember the keywords and all those, the program will allow you to do to issue the commands. Okay, so basically that's what a command is. What else can I talk about under a command? For example, programs that are run menu driven provide menus as a means of providing commands. Today, most programs have a graphical user interface that uses icons, buttons, and other graphical objects to issue commands. So basically, I've already talked about this. So the other thing you have to take note of is the graphical user interface. You have to know what GUI stands for. Okay, it's graphical user interface. Okay, it uses icons, buttons, and other graphical objects to issue commands. Okay, it's user friendly. Okay, so it helps you to enter certain commands in a more faster way and more easily. Okay, the other one we have is user response. Okay, a user response is an instruction which is given by you to the computer by replying to a question posed by the computer program. For instance, do you want to save changes to this changes made to this file? Then you say yes. Okay, the computer will perform an instruction based on the answer that you're going to give it. If you say no, it's not going to save it. If you say yes, it's going to save it. Okay, is that clear? Okay, so I'm just going to finish talking about input devices, and that's where we're going to end. We're going to make up for the other 30 minutes next time so that we can have this one out. Is that okay? Great. All right, so now we go back to input devices. We have established that when you want to enter data, you want to enter instructions, you want to give commands to a computer, you use input devices. Okay, so an input device is any hardware component that allows you to enter data, to enter programs, to enter commands, and to enter user response into a computer. Okay, some of the devices which are mostly used input devices, we have the keyboard, we have the pointing devices such as the mouse, the trackball, the joystick, the touchpad, and the light pen. These are pointing devices. Okay, So the most common one that probably you are familiar with is the mouse, and also the touchpad, of course, because we have these personal computers where we use touchpads. Okay, like right now I'm using a touchpad to enter this command. So the next one is a scanner. The same scanners that we know. We also have voice input systems. We have webcams where you input videos. We also have barcode readers. The barcode readers which are used in supermarkets. We also have the optical mark reader. We also have the scanner and the optical character recognition, magnetic strip reader, the microphone, and the sensors. So you can just pay attention to the common ones so that you're able to remember when they say give maybe list four input devices or something. You have to at least pay attention to the ones that are common that you won't forget. For instance, the scanners, the microphone, the sensors, the keyboard, the mouse, those ones. Okay, we're already familiar with the keyboard. I don't know if I should talk about this, the mouse. So basically that's it about input devices. You also have to
Joystick.
yeah,
Which one? Yeah, joystick. Oh, joystick I know too.
the joysticks are mostly used in they use them so much in games, like those guys who play games. I don't know if you do gaming, but they are used so much then.
Oh, okay.
Yeah, and also in vehicles. Joysticks are also found in vehicles.
Oh, yeah.
Yeah. So basically that's about input devices. We shall continue next time and look at output devices. Is that okay?
It's okay.
Okay, great. We end here. I have to join another class at 19 hours. So we shall meet on tomorrow. Can we meet tomorrow?
Yes, yes.
Okay, great. We shall meet tomorrow. Then have a good night.
Not the same.